Bismillah Rahman Rahim. So here we will discuss that how you will formulate a hypothesis for your research. Sometimes we also say it research hypothesis. So formulation of hypothesis is also a very important component of your research methodology, because after having your literature review, this is your main task, to formulate your research hypothesis. So what hypothesis is, or what research hypothesis is what you can easily define, or simply define that it is an assumption about relations between variables. So while we are conducting research and while we are doing research, we sometimes we build certain hypotheses. Not necessarily that every kind of research needs a hypothesis. Some researches we are nowadays we more often inclined towards defining research objectives and research questions, and then we will try to find out the answer of those research questions. And obviously though all those research questions are aligned with your research objectives. And in other case, what we do is we define hypothesis, which is what is you can say is an assumption about relationship between variables. So there are different kinds of variables we are talking about. One is called the dependent variables, and other one is called independent variables. So in other words, we also interested to know what is the relationship between various kinds of variables. So hypothesis can be defined as a logically conjectured relationship between two or more variables expressed in the form of a testable statement. So you build a relationship, but it is also important that you represent it in a manner which it can be verified, it can be tested. uh, so you can build a relationship between various variables. Let's suppose you can say that there, there is a reaction of a certain COVID vaccine in the blood levels of people having age less than 40, or females having age less than 40. So this is what, this is something which is a hypothesis which you build upon. So now you have to verify it, then you have to test it. So obviously you need a data, and you have to collect that primary data. Let's suppose nowadays the vaccination is being done all over the world, even in Pakistan. So they are, as you know, they are wherever we have the vaccination centers, the data is connected to the Nadra data, and you will get a vaccination card, which is basically which informs which has a detail of the vaccination which is being done, when it is being done, where it is being done, which vaccination is used, date and time and everything. So it is being recorded. So let's suppose after that vaccination, those subjects are actually, if they are having any problem, they can go to the relevant specialists or doctors, or they monitor them after the vaccination. So so in that particular case I need to have data from that side. So whenever you build hypothesis, you build hypothesis in such manner. So let's suppose the inflation rate how the inflation rate affects the population who have earning at less than this amount. So you need a certain hypothesis, or whether it is from economics, whether it is from medical side, whether it is from any social perspective. Sometimes we also have such hypothesis. So there we need to test it. We need to verify it. Relationships are conjectured on the basis of the network of association established in the theoretical framework formulated for the research study. So how, from where we know what is the relationship? So obviously that relationship is developed, or you can say is conjectured from where, or that connection is being established from the theoretical framework which you have actually explained in your thesis. So let's suppose if you study the temporal attributes. So you define those various temporal attributes, then you define in your framework what type of relationship these attributes have. Or let's suppose if you are dealing with special attributes, so how, what is the relationship of these temporal attributes with those special attributes? Let's suppose you have your hypothesis that the rise in temperature brings the climate change in Pakistan. So you want to be more specific about your hypothesis. The hypothesis which I just stated is not specific; it is generalized. But you can make it more specific in terms of values, in terms of a clear statement, and then you must have that data with yourself. Means the time related data, and maybe you have the special data which gives you the clear indication that how those glaciers are being melted, or what climate parameters have been changed in that particular location. So how you prove it? So obviously you need to analyze that data. So anything that can vary can be considered as variables. So it is very important to highlight or to indicate the important variables in your research study. So if whatever topic you are doing your research, you need to know the variables, in which variables you are interested on. Let's suppose if you want to build an application for COVID patients, so you need to know what variables are required, or which variables you have to focus. Maybe there are some demographic attributes, maybe there may be some health attributes, and then you try to focus it according to your own research. So a variable is anything that can take on differing or varying values. And obviously, whenever we talk about a variable, so variable itself can have various values or varying values, and we have to study the behavior of those variables. For example, in terms of the age, motivation, income, height, weight, gender, sex, these are all the variables in which we might be interested. Or in other words, from our point of view, from a data point of view, these are also represented in terms of attributes. So whenever we are doing research, we are also interested in attributes. Let's suppose if you are interested in images, so what type of image data is required? If you are interested, for example, in special coordinates, then you need to have those special coordinates with yourself. If you need to have a temporal attribute, what type of temporal attributes are required in your model or in your research study? So where you will focus on. So in any problem, we need to identify those variables. The values can differ at various times for the same object, at the same time for different objects or person. So those values might change. The inflation rate will not remain the same in the country. That inflation rate changes over a period of time. It changes every month, and it is being reported. The change is recorded quarterly, the change is recorded yearly as well. So that is being changing. Sometime, it is, you can say, increases, sometimes it decreases. So there is always a variation. Similarly, I just talked about climate related variables, for example, temperature, humidity. So that humidity levels, that temperature levels, that changes with the passage of time, on various days, on various months. So we can record it with respect to time, with respect to objects, with respect to persons, with respect to places. It depends on the problem which you define. A variable is a characteristic that takes on two or more values, whereas an attribute is a specific value on a variable. So, just want to differentiate between the two, but there is a little difference between the concept, because out of those attributes, actually, we pick the variables. So what it says, that variable is a characteristic that takes on two or more values, whereas that is why it is a variable, because the attribute gives you a single value. So when you compare, obviously, the attributes, you at least look for two or more values, and attribute give you what, a specific value. For example, I just want to know that what is the location of that particular point. So that gives you the location of the particular point, that gives you the specific value. Or for example, I want to know the glucose level of a certain subject at a particular point in time. So that value is being recorded. Okay. So you might have different point of views for that values, and you can relate those values with the other values, and you might have your own point of view. For example, the sex oblique gender has two attributes, male and female. So you can see that there are two attributes which are involved in that. The variable agreement has five attributes, because you might need to record the statement in terms of whether those subjects strongly agree, or they think they are neutral, or disagree, or strongly disagree. So there are five different values which might be recorded. So at least there will be two. So if there will be two or more, then it will be considered as a variable. Explanatory versus extraneous variable. So the variables selected for analysis are called explanatory variables. So whatever the variable you will select in your study are called the explanatory variables. And all other variables that are not related to the purpose of the study, not directly related, you can say, to the purpose of study, but may affect the dependent variable, or what are extraneous variables. So let's suppose I just want to have a computational analysis of climate related variables. So I just picked out the temperature, let's suppose, the humidity, okay, the wind speed, so on and so forth. So these will be considered my what, my explanatory variables. But there are so many other variables which are there as well, which can be taken as extraneous, which might affect or may affect the dependent variables, but they are not treated as the explanatory variables. And then further, we have a further classification that is called dependent versus independent variables. Why? Because we need to build relationships among various variables. So we want to see what is the effect of one variable to the other. What will happen, let's suppose, if let's assume if the dollar rate changes, how it affects the inflation. So this is now what you want to know. You want to have a relationship between two variables. Or what will happen, let's suppose, if the temperature rises. So what relationship we have with the temperature, the water level and the temperature. So we need to know. So that is how we look for various variables. The variable that changes in relationship to changes in another variable is called dependent variable. So that variable changes in the relationship to changes in another variable is called the dependent variable. So whenever we take these with two variables, simple as that, we can take x and y. You can put a graph. So what is change in x will make change in y. So y is equal to fx. Y is a function of x. So you can say the value, actually x will take the values, and according to x, that y will change. The variable whose changes values in the change in other variable is called, the variable whose change results in the change in another variable is called an independent variable. Independent variable is the one that influences the dependent variable in either positive or a negative way. So what type of relationship they have, it depends on the outcome. So we will see what will happen. Okay, if we change the value of x, how the value of y will be changing. If let's suppose if there's increase in the value of x, whether the y will increase, or the increase in the value of x, the y will decrease, or both the things will be happening. So any of such relationship may be observed. So research hypothesis is what is a predictive statement that relates an independent variable to a dependent variable. Hypothesis must contain at least one independent variable and one dependent variable. Remember that you might have more than one independent variables, and similarly you might have more than one dependent variables, and you might have various relationships to study, not necessarily that you have a single relationship or a single statement to study. So you might have various statements of study. So what we call it, a predictive statement. What is a predictive statement? Let's say you can see the change in X will have that particular effect in Y. So if you have such a statement, it's a predictive statement. That, let's suppose, if I say the rise in the dollar exchange rate will increase the population, will increase the inflation rate. So it is what? It's a predictive statement. And then I have to prove it with my computational data. Then I have to prove this mechanism. Or you can also relate it with the health. Let's suppose increase in certain things. For example, the patient having type 2 diabetes are more inclined toward cardiovascular diseases. So that is something which can be represented in terms of hypothesis, and you might take some glucose level as well to represent such relationships. And then you need to collect that data, the primary data from health domain, and then you want to compare it. Either you use the computational analysis, or either you want to use some sort of image analysis, and any other way by which you can prove it. So that is the concept of the hypothesis. Hypotheses are tentative, intelligent guesses as to the solution of the problem. So hypotheses are what? Are not, you can say, the final verdict. They are tentative. So you have to prove it, whether they are correct, whether they are wrong, or you sometimes these are guesses. By having literature review or by having expert advices, you have such concept in your mind, and then you want to prove it from your study. So you are clear from here that this is the hypothesis, and then you want to have a mechanism to prove it or disprove it. Not necessarily that you prove your hypothesis. Sometimes you disprove your hypothesis. That can also be the outcome of the research. The hypothesis is a specific statement of prediction. It describes in concrete terms what you expect to happen in the study. So this is what you want to know, that or you want to predict, and you see that your study will go in that manner. And and at the end of the your research work, you want to prove this mechanism. Hypothesis is an assumption about the population of the study, and obviously when we make an hypothesis, we talk about the population. We're not talking about the minority. We are not talking about the sample. Although whenever you are going with your study and you make your research design, there you will look for the sample. Why? Because you are not able, or you cannot able to collect all the information of the population, because in the limited scope it is not possible to have data of the complete population. So let's suppose if you are interested to know the relationship between diabetic patient and with the COVID, so obviously you might not have the data of complete population. Then you will go for a good sample size. So there you will perform the sampling mechanism, which has certain methods, which is not included in this lecture today, but I will discuss this later on. How you will perform sampling, or how you take samples from a given population according to your study, and in what type of study, how much sample is required. So sampling mechanism, sampling techniques, how much sample is required at least to have a good study. So it delimits the areas of research and keep the researcher on the right track. So it puts the researcher on the right track. Why? Because it has a clear hypothesis, so exactly knows that this is my population, this is my sample, this is my hypothesis, these are the variables in which I am interested to know, and then the look for the results. So, problem versus hypothesis. So, sometimes we go for problem statement as well. We define the problem statement. So, it depends upon the type of research, whatever you do. So, some people say that there is a difference between a problem and hypothesis. Some people say no, hypothesis itself states the problem. So, how you can differentiate these two? So, hypothesis what is an assumption that can be tested, that can be proved to be right or wrong, as I told you earlier. that hypothesis, not necessarily that your hypothesis is true. Let's suppose if you say that temperature has a significant impact on the water levels, but let's suppose your study disprove this thing. So it means that there is a possibility that it might be proved right or wrong. A problem is what is a broad question which cannot be directly tested. Let's suppose in the same problem, the problem statement is that the change in temperature bring the climate changes. So it's a very broad topic. Now, what type of climate changes, which specific thing which I want to study, that is represented in the hypothesis. So problem itself is a broad, it gives a broad spectrum. For example, I want to have a spatio-temporal map of COVID patients. So this is a very broad problem. But when I specify it, what I want to do exactly, there I have to write out my research objectives and the concerned questions. So either I will go with the hypothesis statements, that will be my H naught, H1 or HA, or either I will go for the research questions. It's up to you. Characteristics of hypothesis, it must be conceptually clear. It should be clear and precise. There is no ambiguity in the hypothesis. Hypothesis is clear, whether whatever the statement is. Specificity, it should be specific and limited to scope. Now, research scope is very important. What is your scope? That is being defined in your first chapter, that you know exactly what my scope is, what to be included, what not to be included. So we have to limit ourselves. There is no research where you do not have a limitation. You have to delimit yourself. You have to make a scope. What attributes you look for, what data you look for, in what specific area you want to have a study. So that actually makes your scope. Consistency, uh, it should be for specificity. For example, for a scope, let's suppose I just talked about spatio-temporal modeling for COVID patients. So here I can make a scope. What type of patients I'm talking about, in which region I am talking about, in what attributes I am interested in. That describes the scope. What functions I will want to study, that actually describes the scope of the study. Consistency, it should be consistent with the objectives of the research. You cannot deviate yourself, whether you are write your hypothesis statements or you are writing your research questions. You have to consistent, you have to make consistent with the research objectives, because let's suppose the research objective is to investigate the relationship among the COVID patients and the diabetic patient. That was one of the objectives. Now, the research question, whatever, or the hypothesis, whatever you build, must relate these two specifically. If it has no relationship over there, which is in line with the research objectives, then they are not consistent. Testability, it should be capable of being tested. You can verify it, you can test it. So write such the hypothesis or research questions or hypothesis statements which can easily be tested, can be verified with the data. And last is expectancy, it should state the expected relationship between variables, what relationship they might have. So that is some. These are some of the characteristics of hypothesis. Furthermore, we need to make it simple. We have to simplify the statements. We have to simplify the terms. Objectivity should not include value judgments, relative terms, or any moral preaching. There is no concept of moral preaching in research. There is no moral of such of research, or you cannot dare to judge the value. You just based on the quantitative data or the qualitative data you have, and you need to be very objective. Let's suppose if you are interested in finding out the relationship of COVID positive patient with type 2 diabetes, just focus on the objective. Do not make such statements related to a particular subject, or let's suppose you try to include the concept of religion into it, and you say, okay, these are the Muslim and these are the non-Muslim. And no, there is no need to do it, because then you lose your objectivity, theoretical relevance. It should be consistent with the substantial body of established or known facts or existing theory. That is very important. Whenever you are writing, whenever you are presenting your hypothesis, that must be related with, consistent with what? The established facts. It is sometimes people come out with the ideas which are totally against the fundamental facts or the established, well established facts. Let's suppose it actually contradicts the basic laws. No. Please have a good study. Make your fundamental strong. Do not make such a statement which has no relevance. Uh, and you do not come out with any statements just which can create a fuss, or just to gain any, you can say, importance in the media. No, come, please, while you are doing research, you must cannot deviate with established facts. So there are so many established facts. For example, let's suppose in science, so there are Newton laws. All of those laws are established facts. There is a concept about energy. So lots of facts which are related to energy or force, which are fundamental facts. uh, for example, there are established laws in computational laws, mathematical laws. You talk about various type of theorems, which are well established theorems. So while you are making your models, or you are, or you are using any computing paradigm, please do not negate them without any knowledge. So this will nullify your research, believe me. So if somebody is evaluating your research, who will nullify your research? Availability of techniques. Look for methods. There are so many methods which are available. There are statistical methods, graphical methods, computational methods. So think about various methods and see what type of method and approaches are there. Do not focus on just one or two methods, or sometimes people go for typo research. They just take any thesis and they just try to follow it in the same manner and doing the same things. No, think about various approaches. There are so many approaches, soft computing approaches nowadays, statistical approaches nowadays. We have computational paradigms, uh, network analysis approaches, prediction based systems. So there are so many ways by which mathematical models, so you can verify or test your hypothesis. Um, okay. Sources of hypothesis, how you can know about various hypotheses. So there are various ways you can see on the screen as well. I have already discussed with this, in the previous presentations. So I'm not going to review this. So with this, I conclude over here, and I hope that you understood the concept, and hopefully we will have our next lecture, and we will continue discussion on the same topic. Thank you so much.